once you have an understanding of the maps and all of its symbols, its colors, its shapes, its angles, and a compass, we can do some interesting things by combining the two of them. Sure, I use the map all the time, and I pull the compass out just occasionally, but what the compass does in combination with the map is it allows us to orient the map, and orient means to align it to the terrain, so that's a definition you need. And then it allows us to take bearing angles off of an oriented map and apply them to the real terrain, because of course the terrain is by definition oriented to itself. And then the last thing we can do is we can take bearings out of the terrain and apply them back to the map, because we might be able to see an awful lot on the map. We can always see a lot on the map. We can't always see it when we're down in the terrain. Sitting up here today, yeah, we're at a high spot that's somewhat like a map view, so we do get to look around. But once you're down in those trees, like right here in front of me, you can't see much of anything, and it would be nice to have a compass angle to help keep you on track in the direction you're going, and even enough to check on a trail to make sure you're on a trail that's going in the right way. So I want to align my map to the terrain as best I can. And I can do this in a bunch of different ways. One is going to be with the compass that we just pulled out. Another way is if I can identify a bunch of things in the terrain that I can then also find in the map, and I can then get them so they line up roughly with each other. So looking out here in the terrain, that's Silver Lake, and up here is Twin Lakes. So I can also find those on my map. So here is Silver Lake, here is Twin Lakes. So if I tilt those so they're roughly in the same alignment, I know I've got the map fairly close to what I am trying to do. I can also look over here and see, poking out in the sun right now, Millicent, Twin Lakes Pass, and the Honeycomb Cliffs. Now if I didn't know all these areas, that would still be for me to discover on the map. But if I've got the two lakes lined up, let me lift the map up in those places, and here are the two lakes lined up, I should have over here Mount Wolverine, Millicent, and the Honeycomb Cliffs here, which should be roughly where they are out here in the terrain. So I can see from my compass that north is roughly off here to my right, which means I'm looking pretty much west almost. This is an illustration of magnetic north versus grid north, true north, and at the time this map was made, which is decades ago, the declination was 15.5 degrees east of grid north, true north, and I'll show you again in a second how I came up with Brighton area as 11 degrees 3 minutes. Before I left the house, I pulled up my Brighton quadrangle that I knew I would need, went up here to one of the corners where you can see the latitude and longitude there, 111 degrees west, 30 minutes, and north 40 degrees, 37 minutes, 30 seconds. And then I went to my computer where I have the NOAA website pulled up on geomagnetic calculator. So if you want to stop and copy that down, here is the page that I came up with. And then here's where I have entered the numbers, same that you just saw on the map, and then coming down to the calculate. So press calculate, this window comes up, and coming up here to the top you can see the latitude and longitude that we pulled off of the map, 40 degrees north and 111 degrees west of Greenwich, England. The date there, July 4th, and the declination is 11 degrees and 3 minutes, and changing slowly every year. Here's the map. It shows you there's Park City, the corner of the map, just above the little town of Brighton. So there are three main ways to deal with declination. in the practical world. We're going to do the one where we compensate at the map. You can also compensate or deal with it at the compass. There are some compasses like this one that has a little bit of a screw. Let's see if I can find it. Hard to see. There we go. And a little screwdriver that comes with it. And I can turn that screw and change the alignment so that the top of red Fred in the shed no longer points to the 0. So for here I have to subtract 11 degrees. So that's one way. And the other way is to do it mathematically. And every time you take a bearing out here on the map or in the field, depending on whether you're going from the field to the map or the map to the field, you either add or subtract 11 degrees. So you can do it at the map, which I'm teaching. You can do it mathematically, adding and subtracting, or you can do it with a compass that is adjustable. We are going to go very simply and use the map by drawing magnetic north lines. And then we will always be reporting magnetic numbers. So you have to be sure, whoever you're working with, if they're accustomed to working in true north numbers, one of you is going to have to make a change, because these numbers will always be magnetic north numbers. They'll point to the right place, but they'll be 11 degrees apart. A quick reminder of how to do magnetic north, get a magnetic north line on your map. We're going to use the compass as a protractor, so you can see that the red Fred is here, the north, the N is here, the direction of travel arrows are going straight up the long axis of the base plate. So we are going to use it just as a protractor. So we just read that the magnetic bearing variance is 11 degrees to the east. So I'm going to tilt this arrow, that yellow-green arrow, to 11 degrees. So now I have the 0 mark on 0. These are the orienting lines we're going to use in a moment. And I have tilted the edge of the compass and these red lines 11 degrees. So now I can draw that 11 degree. I just have to get north-south on the north-south lines on the map. And then I can draw an 11 degree tilt to the east. So flipping this map over, I'm over on this side of the map. So I can use the margin of the map as the only part that we're sure. In this case it's green versus white on a black line. That's the only spot that we're sure is a true north line. So I can set up my N and my S. So that's directly over the edge of the map, not the edge of the paper, but the edge of the map. And then that means my two outer edges are tilted at 11 degrees. And then I like to put little train tracks and put magnetic north written right on those lines, so I know exactly what they're all about. MN, magnetic north. Drawing my own magnetic north lines is necessary, it's helpful, it's useful, because the one and only thing that this compass does on its own is that needle swings to magnetic north. So there it is under my fingers, and it's off to my right, your right, and I need to turn the compass until I get red Fred, the red end of the compass, into that box that looks like a shed in this case. So Now I have Red Fred in his shed. I need to lay this flat. It's going to be harder for you to see. And then I need to turn my map until that needle is back over the shed. And let me use this line over here. This is one of my magnetic north lines. And I can now get the needle directly over the magnetic north line I drew by rotating the two of them until they're just right. So now my map is lined up. I would normally anchor this down onto the ground. The better place to orient your map is to anchor it to the ground, rotate it until Red Fred is in the shed, and then start laying rocks along the edges to keep it in place. Instead, I'm going to, yeah, there you can see I bumped it out of place, but it's very quick to get it back in line and put Red Fred back in the shed and then pull the camera up. And just like the map, there is Silver Lake. Here's Silver Lake on the map, which means Twin Lakes should be just up that way. And there's Twin Lakes in the terrain out there. So my map is now aligned to the terrain, except that I keep bumping it. And so we have oriented the map. The definition of orienting the map is to align the map to the terrain. Using a compass this way is a pretty accurate way. We were very, very close just eyeballing because we have so many identifiable features, but you don't always, so you want to orient your map with a compass. This is when I use a compass, which is fairly rare. This is the purpose that I have for it, is to help me orient the map a little more accurately. And then I can be more sure that I'm aligning things out in the terrain to things on the map rather than just guessing. With a correct orientation, the objects on the map will have the same spatial relationships to each other as they do on the ground, so we can take bearing angles on the map and apply them to the ground, and we can take bearing angles from where we're sitting and apply them out here in the terrain. So we can give directions then, saying that from the outlet to Silver Lake, if you go 235 degrees, you'll get to some place. So we would have to measure that on the map first. And then we could give those directions to somebody that's coming out here. For taking a bearing in the field, or to apply it to the field, we can take it off an oriented map. We can take bearing angles because the relationship is correct. That's why we oriented it. So this map will be, once it's oriented again, any bearing angles I take off the map while oriented, I can apply out there to the terrain. So I can move out here and apply them. So how we do this, we need to have the map oriented. So once again, the way we orient the map, and it's pretty close, we put one of these orienting lines over the magnetic north line that we drew, and then get Red Fred in the shed. So this had remained almost perfectly oriented. And then let's say we want to send a hiker from Silver Lake over here to Lake Mary. And any angle, bearing angle, magnetic north compass bearing I take here on an oriented map will be able to apply directly to somebody standing down there at the inlet to Silver Lake. So the way I do that is I'm going to put the near edge of the compass nearest the axis and the needle at where I want to start, and then I'm going to lay the side of the compass to where my destination is. And sometimes you have to draw a line, but this one's pretty short, pretty close. So we can just lay the compass on there. And then put Red Fred in the shed, and he's already in the shed. So this must be very close to a north-south line. Should be off by 11 degrees because this is a magnetic line. And if we go out here to read it, So here's the direction of travel arrow for this compass. Often it is a line. This one instead has two lines, but it's parallel to the edge of the base plate. So we put the edge of the base plate here, but we actually read the number off the center of the compass. So right here, this one has a little triangle, and it reads, looks like 174 degrees. So a person can take this compass now and stand out here at the inlet to Silver Lake, stand there, put Red Fred back in the shed, and the edges of the compass, or those two red arrows, are going to point up here to Lake Mary. And if they needed to, they could walk just a straight line going from Silver Lake, straight line to Lake Mary. Fortunately for them, there's a trail, so they won't have to do that. We can also take bearings out here in the terrain and then turn around and do the opposite, and that is apply them to the map. So we have a couple of fairly prominent features out here, one of which is the highest summit of the Honeycomb Cliffs, and then this little bump under the cloud is Tuscarora. So I already know that, so I can then use those, and from where I'm sitting, take a bearing out from here, draw it on the map back to me. I can do the same thing from Tuscarora, draw it on the map back to me, in case I don't know exactly where I am. Right now I'm sitting up on a ridge, so I know I'm along that ridge, but just exactly where am I on that ridge, we can figure out from the map. So to take a bearing off an object out in the real world, I want to stand up with just completely facing my object. I want to have my hips, my shoulders, my knees facing that object, and then I'm going to move the compass up and down so I can get a good look at aiming off if it has a center line. If it doesn't have a center line, then you're going to be aiming off the side of the compass. So I want to put this on the summit of Honeycomb Cliffs, and once I'm convinced all of my being, my shoulders, everything is facing the Honeycomb Cliffs, then I'm going to peer out over the edge of the compass and look straight down on it and rotate the dial until Red Fred is in the shed. Then I'm going to just move back a couple of times, make sure that I'm pointed at that highest point, double check, I've got a little bit of adjustment, checking again. Okay, I'm pretty convinced. And now when I read the number at the top, I have 252 degrees. So now I'm going to apply the bearing that I took off of the Honeycomb Cliff over here and apply it to where I am sitting. So first thing I have to do on the map is be sure to check my map's orientation, and once again I do that by putting a orienting line over a magnetic north line, checking that Red Fred is in the shed. It looks like we can adjust by just that much. Then I kept that 252 degrees in the compass. Doing that orientation check didn't change that. Here are the Honeycomb Cliffs. This is the one that I took the bearing off. So I want to put the far end of the base plate right over that, and then put Red Fred in the shed and start drawing that line. Okay. My compass is too short to draw it all the way, so I'm going to have to move the compass and do it again. Or it would be more accurate if I pulled out another piece of paper, a map, a ruler, and continued that line by drawing along the edge of the paper. And look, it goes right over Silver Lake and somewhere up in here to where I am. It's a pretty crooked line. Alright, then I need to go get a second bearing. Ideally, you want your second object to take a bearing on when you're triangulating. You want it to be roughly 90 degrees. These are probably a little less, probably closer to 50 degrees. But out here in the terrain, we have a peak that I can identify. So let's take a bearing off that. Again, I stand here, I face exactly right at it, and really get the compass direction of travel arrow, sides of the base plate right at that peak. Then I'm going to turn the dial. Red thread is floating there, pointing at magnetic north, and I put red thread in the shed, get it lined up, and then when I pull in here, I can read 200 and it looks like 6 degrees. So this is Sunset Peak, not Pioneer Peak, so I named the wrong one. But we did get a bearing degree of 206 degrees. So we'll put the end of our compass out here and draw that line back to where we hope to mark where we're sitting. Once again though, we might have bumped the map out of alignment, so go to a magnetic north line, put an orienting line across it, turn it till red thread is in the shed, then anchor it there, hold on to it. Need to put the 206 degrees in the compass. I could have left it there, but I didn't. Okay, 206. Put it over here on Sunset Peak, which is this one. Then put, oh, went the wrong way. Keeping it on Sunset Peak. There's Sunset Peak. And turning until red thread is in the shed. Okay. Then same thing, I want to draw that line back. From Sunset Peak, then continuing that line back, and it crosses the other line. So these two lines, especially when I draw that first one a little bit straighter, so here's the honeycomb line. And where those two cross isn't up on a ridge, so I've missed by a little bit. They cross here, but this is the ridge, so I'm somewhere along this ridge. And now I can be reasonably sure that I'm out here on this bump, probably not this one, probably not this one. I could take another bearing off somewhere else and draw that line and see where that crosses if I wanted to be even more confident about where I am. So this is the third use of a compass with the map. And it's pretty rare that I use it because I can usually eyeball it if I have a good enough view, but I can't always. Sometimes the terrain just isn't that distinct. But you can see why it's called triangulation. I have two lines coming together, forming a bit of a triangle angle out here, and I'm here. It does require that I can recognize and identify two features out here in the terrain, and then I can use those to come back to me, and then I have to use the logic of, okay, reading these contour lines, does it make sense? And looking around at everything else, does it make sense? Is that side of Silver Lake in line with the peak? So here's the peak coming down, there's the edge of Silver Lake. So that's something we call a range line. If I can line things up, it can help me orient those. And then over here we're coming across Patsy Marley, Wolverine, Millicent, Tuscarora, Lake Catherine Pass, let's see, Sunset Peak. As we keep going, there's Pioneer Peak. And this is the ridge, and down below us is Hidden Canyon. So those are all things that we would take a look at the map and see if they all make sense. You can practice this skill of triangulating or taking a bearing out in the field in any room. All you need is a blank piece of paper that's going to represent your map and represent the room, and that same compass. What I'm going to be doing, instead of taking bearings off of peaks, I'm going to take a bearing off each corner of the room, which has a lamp in this case, and take that bearing angle and draw it from the corner of the map right here for that corner of the room. This corner of the map represents that corner of the room, and the lines that I draw off there will show roughly where I am in this room. So let's just go very, very quickly and do this. So if I orient the map to the room, just get all my straight sides together, my tiles on the floor help me with that. And I can stand here and take a bearing, point everything right at the corner of the room, put red Fred in the shed, put the corner of the compass in the room and rotate until I have red Fred in the shed. Then I can draw that line across the room and do it again from this side and put red Fred in the shed again and draw that line also across the room. And then you can see that I'm offset in the room part way. I'm going to call this skill 3A because it's just the opposite of triangulation. If I know right exactly where I am, right here, I can do the reverse of finding something out here on the map or out in the terrain and looking at it and saying, huh, I wonder which peak that is. So if I'm looking up here in the terrain, we can zoom in just a little bit. I see a peak way off in the background and take a bearing on it, get red Fred in the shed, bring that bearing back down to where I'm sitting here, and then I look out there and I'm looking through. I can see that I'm looking through a number of things, including this pass right here. There's a small peak, and I keep looking because it's way off in the distance. And then I can see, okay, that's Devil's Castle. So the three skills that we're working on here are the three map and compass together skills. And the first one is orienting the map. We did that originally just by kind of lining things up. But then we were more accurate by drawing a magnetic north line and then using the compass, which points to magnetic north. So got the needle exactly in line with the magnetic north line that we drew, and we knew the angle to make that because we looked it up on the computer ahead of time. There is a drawing down here at the bottom of the map that's not very accurate, but at least it tells you which side you need to tilt your angle toward. So it's good for that. We had to look it up and come up with 11 degrees 3 minutes versus 15.5 degrees. So that's the first one, orienting the map, getting it so that it is lined up to the terrain. So here's our map and out here in the terrain. that led us to being able to take a bearing off the map, because on the map we have a great view. It's a terrific helicopter view of everywhere. But because the map is oriented, any bearing that I take on the map, on an oriented map, I can then apply to the ground. So up here, it's no problem. We can look around, we see these 3 lakes. But when we're down at the lake itself, we can't see the other 2 lakes. So even knowing that we need to go, I've forgotten the bearing angle that we had, it was almost due south, like 276 degrees, something like that. That we could, even have a compass and check it every once in a while and see that we're generally traveling south. We can refine that later in another lesson. But that's taking a bearing off an oriented map and turning around and applying it to the terrain. Then our third skill was to be able to identify 2 features out in the terrain. And we had the honeycomb cliffs, and then we also had, there we go, Sunset Peak. We could take a bearing up here in the field from honeycomb back to us, from sunset back to us, and then apply that line that came off of honeycomb across Silver Lake, across Hidden Canyon, across the Brighton Loop, and there we go, honeycomb across the corner of Silver Lake, past the Brighton Loop, and then the only way we knew how far to follow that line was to take the second one, which was off of a bearing of 206 degrees, I think, off of Sunset Peak, and then follow that back. We would, if we could see Dog Lake, which we can't quite from this angle, our line crossed Dog Lake, and crossed the other line we missed by a little bit. We're up here on this ridge. I would say that the honeycomb line was a little more accurate. But I also wiggled while I drew those. So then you look around and make sure you've got that it makes sense. So the 3 skills: orienting the map, applying a bearing from the map to the field, and then applying a bearing taken in the field, putting it on the map to help triangulate back to where we are sitting here